What's up, guys? I've been messing around in the Flax game engine for the past few days, and I've been working on a mini version of Call of Duty Zombies. And I've spent most of that time trying to figure out how to get the zombie AI working in this engine. Everything else has been a pleasure to work with. It's just the documentation is unfortunately a little bit lackluster for the behavior tree. So I'm just going to show you guys a simple way to set it up the way I did it for the zombie. So first of all, let me show you guys how it works. So we got the zombie guy. He can follow you around on the nav mesh, and if he gets close, it can start damaging you, as you can see on the health bar. So yeah, I can back away from him. It starts falling again, and I can shoot it to kill it. So yeah, first of all, just a little bit of setup. Since I want my zombie to follow the player, I had to set up a nav mesh to get the AI working properly. It's pretty simple. You just go to your editor, you press new, you go to navigation, and then nav mesh bounds volume, and this will just spawn a big box around your scene. So you could just resize the box to whatever size you want to fit your whole scene, something like this, and then you just build it, and then it automatically bakes it. If you can't see the nav mesh, go to your viewport and press P. That toggles it. You can also go to view, show, navigation. Alright, now that that's out of the way, to set up our behavior tree, we have to make a behavior tree asset. So all you have to do is go to somewhere in your file explorer, go to new, AI, behavior tree. And that's pretty much it for that part. So when you go into it, this is the final product of what I made, but essentially the entire behavior tree is made up of all these different nodes. It starts at the root and goes down the tree using different variables to decide which way to go. These are all very customizable, so it can be expanded upon a lot more than what I have it right now. I'll show you guys more about this later, but this is kind of just what it looks like right now. The first thing we have to do is actually put this on our zombie, and it's pretty simple. You just go over to your zombie, and then you go to add script, Flax engine, and then behavior. So that spawns in the behavior component, and then you can just drag in your behavior tree assets into the box, and that's pretty much it for that. Alright, so one of the most important parts of our AI behavior tree is the blackboard. So basically what a blackboard is just a container for all the information that our AI needs to know. So as you can see in here, it's really simple. I just have some variables that reference like the target, actor, and the position, the speed of the zombie, and like a boolean for if it's close enough to start attacking. It's very simple. You can add more variables if you need to. Okay, so to actually have our behavior tree use that blackboard and have the information it needs to run the tree, you have to go over to root, go over to blackboard type, and then you just search up your file. Mine is called blackboard zombie, and it's right there. You just select that and it's connected. Alright, so the next thing that you will want to do is you actually have to create a script to control your character. I didn't mention this earlier, but the zombie actor should be a character controller. You can see it right there if I hover over it. This will actually allow us to code the behavior and make it move. It lets us add gravity, and yeah. So you'll want to add a script for that, and I'll show you guys what I did. Okay, so in the zombie controller script, right now it's extending script and iDamageable. That's just an interface. It's just so I can damage the zombie when I shoot it. You don't have to worry about that too much. I just have the variables that I need to push to the blackboard, so the AI can actually know where it needs to go and what's happening. I also have a reference to the behavior itself, so that's what this little script is right here. I just have some variables for the gravity, and then this is for the interface, the health. Alright, so in onEnable, I make a quick reference to the knowledge component of our behavior component. So basically, that just lets us access the blackboard that's connected to the behavior tree. So if you go to behavior component.knowledge.blackboard, and then you convert that to your Blackboard script here, that basically just lets you set the variables. Yeah, it's pretty simple to set the variables and edit them at different points. All you need is a reference to the Blackboard. As you can see, I use level.findActor, which just searches through the entire scene to find the player. Another way you could do it is have a collider that's set to trigger, that's linked to your zombie, and then once that triggers, you can find your player then. But since it's kind of like a Call of Duty Zombies clone, the zombies just know where you are. So I just search through the entire level. So the next part is the onFixedUpdate method. This is basically just called a certain amount of times every second. I think it's like 30 or 60. It's just a very consistent update method. It's very good for physics. Yeah, so this first part is just adding some simple gravity to the zombie. As you can see, I just change the velocity if it's off the floor. Nothing crazy. Now, for the actual AI part, first I check if the player target exists and I have a reference to it. And then I make the zombie look at it. I access the knowledge again, so the Blackboard, the same way we did up here. I set the target position to the player position. Right now it's just reference to target, or to knowledge.target actor. It's just the player, same thing. I also set the is in melee range variable using a tertiary operator with a distance check between the two positions. It's pretty simple, it just outputs true or false. It's very helpful for controlling the flow of the behavior tree. Alright, so now for the most complicated part. If you saw in the behavior tree earlier, I had a custom node called the melee attack node. It extends behavior tree node, and that's just so I can use it in the behavior tree. So first of all, in this script, I declare some variables that I can edit in the inspector for the actual attack itself. And then here we have to make a private struct for the state of the behavior tree. So it's a little bit confusing, but basically you want to put any variable that changes during the runtime of the behavior tree in this state, and it makes it so it can actually track these changes. These variables up here, they kind of just stay the same the whole time, so you don't need to worry about that. Make sure to put this decorator. To be honest, I'm not quite sure what it does, but it was in the documentation, and I think you need it for certain memory management reasons. Alright, so the first thing we have to do after that is call the initState method. It's a built-in method for behavior tree nodes. Basically, it just gives us the context of the current state of the behavior tree. So it just gives us like the data of what's happening at this point in time. When we initialize it, we basically just have to make a new state. And you can see we set the timer to 0 and the attack trigger to false. And then we have to actually add it to memory. Since we're using structs instead of other types of variables, we have to kind of manually control the memory usage. But luckily there's a built-in function for that. New state, you just put in context.memory for the location in memory, and then the state. Next, for the release state, it's basically the onDisable method, but for behaviors. I didn't mention it earlier, but I wrote it above as well. In this thing, it's kind of the opposite of the init state. So we have to reference our state by pulling it from memory. So you can see we call getState, and we use the same address that we used up here. So that just gives us a reference to the state that we plugged in initially. We can reset it or not, it kind of doesn't matter. Right now I just set it to default. And then finally, we use the built-in method freeState to just free up the memory. Alright, for the update method, it's actually pretty self-explanatory. This happens every tick, I guess, of the behavior tree running. It gives the same context variable, and what's interesting is it actually has to have a return type of behavior update result, so I'll cover that in a second. First, we have to get a reference to the state, kind of like we did up here. This part is to get a reference to the player actor from the blackboard. So this, remember? If it can't find it, it just fails and it just returns to the root of the behavior tree. So yeah, the behavior update results, there's 3 types. There's failed, running, and success. Failed immediately returns it back to the root of the behavior tree. Running doesn't really do anything, and success makes it continue. Alright, then, so I just increased the timer variable that we made with the delta time variable from the context. Like I said earlier, the context gives us a lot of data about the state of the behavior tree, including delta time, so it's very helpful for timers. Then I just check if the enemy has attacked yet, and if it hasn't, I just make it attack in this little block right here. So I just set the variable true. I get the iDamageable script from the target, which is the player. Like I said earlier, this is an interface. You don't have to worry about this too much, but it's just one implementation of this. I call it the damage function. Right now it's logging the damage, but you don't have to do that. Alright, the final thing here is just if the state timer reaches the attack duration that we set in the inspector, it returns behavior update result dot success. So that's it for all the scripts for this behavior tree, and now it's just setting up the nodes in the inspector. Alright, so back to this screen. First of all, make sure that you choose the behavior that we're editing, so it's the one that's attached to the zombie. So again, just going over these nodes. We start at the root. This happens like every update. You can see that it loops right here. It starts from the root, and I added in a selector node. So what this does basically is it goes from left to right on the nodes below it. So first it checks this node. If this node fails, it continues over to the next one, and so on until it reaches the last one. In this node, this is just a basic sequence node, but you can see this knowledge boolean thing attached here at the top. This is called a decorator. You can add decorators in this little menu here. It's basically just some modifiers that help control the flow of the behavior tree. So right now I have a boolean check on it. Basically, it just checks if the player is in the range of the attack for the zombie, and then it accesses the variable from the blackboard. If it's true, it continues down this branch. Finally, I added my custom node here, the melee attack. If you right-click anywhere in the editor, you can see the custom node show up, and any other nodes you add will also show up in this section. In here, I can edit any of the variables for the actor. So the attack duration, damage amount, and the target. Now for this other branch, the chase branch. So this here is just another sequence node that I named chase. So this is just like for the following behavior. Right now it doesn't have any decorators on it, so it just passes through every single time after checking this node. Alright, the final thing that I implemented is the move to script. So this is just a built-in node, as you can see right here. And it just takes a few different variables, such as the target actor, target location, and a few other things. It uses any nav mesh in the scene to navigate the zombie. And that's pretty much it. You can see I customized some variables in here, not too much. But the most important part of this node, or the setup I have, is the acceptable radius. The way this works is that when it gets to this move to node, it doesn't actually progress until the zombie has actually reached its target. And by default, the acceptable radius is 5 centimeters. So basically, it never reaches the target fully. And that means it gets stuck in this loop forever. Basically, you have to increase the acceptable radius to something like 100 centimeters. So it actually stops moving and it can check the other branch. Otherwise, it gets stuck here forever. And with that, that is basically everything you need to set up a simple behavior tree. Once again, we can run it, and the zombie can damage the player. You can definitely add more behavior to this, more complex actions, and many other things. The behavior tree system does seem to be very powerful, but like I said, documentation is a little lackluster, unfortunately, so hopefully that can improve in the future. But overall, I've really been enjoying using this engine. I also use Godot, and it has a similar lightweight feel to that, which I really like. It also has really impressive graphics, maybe even comparable to like Unreal Engine or something. With that out of the way, that's pretty much it. Thanks for watching, and I hope this was helpful for your behavior trees.